In this module, we're going to talk about mass percent composition, what it is, how to find it, and how to use it. So this is what mass percent composition is in terms of chemical compounds. It's just the mass of one of the elements in the compound divided by the total mass of the compound times 100. So for example, let's say we have a generic molecular compound, A sub X, B sub Y. Remember the A and the B stand for the symbols of the elements, and the sub X and sub Y stands for how many of each there are in that compound. So if we wanted to find the mass percent of A in this compound, we just take the subscript X times the molar mass of A divided by the molar mass of the whole compound times 100. For example, let's say we wanted to calculate the mass percent carbon in ethanol. This is ethanol, CH3CH2OH. We just take the total mass of carbon in 1 mole of that compound. So there's the subscript is, there's 2 carbons, one here and one here, right? So 2 times the molar mass of carbon, 12.011. I'm not putting any units in here because the units all cancel out, and the units that you get for an answer is just percent. So anyway, 2 times the molar mass of carbon divided by the total molar mass of the compound. So 2 carbons, 6 hydrogens, and 1 oxygen, right? 2 carbons, 3 plus 2 plus 1 is 6 hydrogens and 1 oxygen. Times 100, work all that out, and we get about 52.144% carbon by mass. That's the mass percent carbon in ethanol. Now we can do the same thing for hydrogen and oxygen in ethanol. So this 46.069, that's what you get when you add up all the molar masses of the elements in the compound. So I just combined them all. I did the addition multiplication. So there's 6 hydrogens in ethanol times the molar mass of hydrogen divided by the molar mass of the compound times 100, 13.13% hydrogen, and for oxygen we get about 34.728%. When you add up all the mass percents, they should come pretty close to 100. Now, if you add up the numbers I have here, you don't quite get 100. I think you get 99.999 or something like that. But that's because I just wrote down the first insignificant figure. When I use all of the digits in my calculator for all of these numbers, it comes right out to 100%. But anyway, when you're doing this, it should come really close to 100%. Now, we can use the mass percent as a conversion factor if we know, for example, in ethanol, that it's 52.144% carbon by mass. The conversion factor would just be that there are 52.144 grams of carbon in or equal to 100 grams of ethanol. It doesn't have to be grams, it could be kilograms, it could be ounces, it's a ratio, right? As long as it's the same on both sides of the equal sign. And the percent oxygen is the grams oxygen in 100 grams of the compound, and same thing for hydrogen. Now, over here, the numbers on the left-hand side of the equal sign they're not exact. They depend upon your calculations, however many sig figs. But these 100s, these are exact numbers, right? So they won't limit your sig figs if you use these conversion factors for calculations. So let's do that. So let's say we wanted to find out how much ethanol you need in order to have 5.199 grams of oxygen. Well, to get 5.199 grams of oxygen, we just use the conversion factor that involves oxygen and ethanol from what I just showed you. Making sure the units cancel, we see that we have to have grams of oxygen in the denominator, so that puts grams of ethanol in the numerator. Work this out. Remember the hundreds exact. 4 sig figs from here. Get about 14.97 grams of ethanol required to have that many 5.199 grams of oxygen.